Generalized topologies with associating function. Assume that W is a non-empty universe and we have certain mu contained in the power set of W. And we say that mu is a generalized topology on W if and only if empty set is in our family, and this family is closed under arbitrary unions, as you can see here. In such a case, we say that W mu is a generalized topological space. The elements of mu are named mu open sets or just open sets if there is no risk of confusion. And we define interior of any set as the union of all open sets contained in A, as always. This idea of generalized topological space has been investigated by many authors all over the world. Perhaps it was Csaszar who has started very systematic study of these spaces. Moreover, we may also discuss so-called infratopological spaces which are closed under finite intersections but not necessarily under any unions. Well, this has been made, for example, by Alaudari and by us. See the bibliography. But now we have another concept, more, well, slightly more sophisticated maybe. Because, as we can see, the whole universe of a generalized topological space may not be open. Hence, some points are, in some sense, orphaned. They're beyond any open set. Because they are beyond the biggest open set, the union of all open sets. In this video, we shall assume that such points are associated with certain open sets, open neighborhoods, by means of a special function F. We define GTF structure as a triple, like here, where we have non-empty universe W, generalized topology mu, hence we have the biggest open set, and we have certain function, and it's defined in the following manner. If our point, our element, belongs to the union of all open sets, mu open sets, then we just say that his open neighborhoods are his elements of his FW. But if our element is beyond any open set, it's here, then we just say that any set X is in FW. If it is in FW, then it means that it should be open in the sense of mu generalized topology. So this is just an arbitrary mapping. Yes, each W, small w, which is beyond any open set, gets certain family of open neighborhoods which are somewhere inside this set. Well, just as you can see here, yes, for example, this point gets, well, this blue family of open neighborhoods. But he does not belong to any of them. Moreover, we may introduce the following notation. A to the power of -1 is the set of those elements of our universe for which A is in their Fz family. Well, some very simple examples of our spaces have been listed below. Of course, they are rather trivial and finite, but you may find less trivial and even infinite examples in our papers in the bibliography. The notion of F interior, which will be introduced on the next page, is based on the intuitions arising from the typical understanding of openness. However, one must note that there will be no full analogy. And here we have F interior. Small w elements is in F interior of certain set A contained in our universe, even only if we may find G belonging to FW so connected with our small w, such that G is contained in A. Some basic properties of this, in some sense semi or quasi-interior, have been listed below. As you can see, if A is contained in B, then F interior of A is contained in F interior of B, and so on and so on and so on. For example, if A is contained in F interior of A and F interior of A is contained in the biggest open set, then of course A is also open in the sense of this generalized topology. And you may check also other properties and the intuitions which are, beyond them. Moreover, we may prove that F interior of W, capital W, of the whole universe is equal to this whole universe even only if for any element its family F is not empty, so contains some sets. And moreover, F interior of empty set is empty set, just like in the case of typical interiors, even only if for any element empty set does not belong to Fw. As for the definition of F interior, it's modeled after the standard definition of interior in generalized or not generalized topological spaces. But note, however, that in general we cannot say that F interior of A is contained in A. Well, to see this, it's sufficient to consider any open A and any element which is beyond the biggest open set, such that A is in Fw. Clearly, W is in F interior of A because of this definition. But W does not belong to A. What is less surprising is that sometimes A is not contained in F interior of A. But this is, typical for any interior. For the reasons above, it's sensible to consider at least three concepts related to the notion of openness, and they've been extensively discussed in our paper, that the set can be F-open, downward F-open, DFO, and upward F-open, UFO. We may prove the following theorem. If we have GTF structure and certain element in our universe, then Fw is non-empty even only if there is F open set G contained in W such that small w belongs to G. And you may find proof in our paper, in our bibliography. I would say that right to left direction is clear, but left to right is slightly more complicated. And we may also think about higher level of openness. Assume that we have GTF structure, and let us define EW as the set of all F open sets, not open, but F open sets to which W belongs. We say that W belongs to this A interior of A if and only if there is S which belongs to EW, such that S is contained in A, where A is a certain set. And we say that A is E open if and only if E interior of A is equal to A. And then we have this final theorem. Assume that we have certain GTF structure, and EO is a collection of all E open sets with respect to mu and F. And then EO forms a generalized topology on W. And moreover, if for any small w belonging to our universe, its family is not empty, for any, then EO is a strong generalized topology. So if we have certain generalized topology mu, then using F, we may find EO as a strong generalized topology on this universe capital W. And many other properties have been proved and discussed in our paper. Also, the concept of convergence and generalized sequences and nets has been discussed. So I encourage you to consider these spaces and to discuss them and to investigate them and to expand them. Thank you very much for attention, and this is our bibliography, as you can see.